Every map you have ever looked at, from that, crumpled road atlas in your grandfather's glove box to the slick, glowing interface of Google Maps on your phone, is a lie.
Wow. Okay, that is quite the opening salvo. You're coming out swinging today.
I am. But hear me out. We have this blind, almost religious faith in maps, don't we?
Hmm.
We treat them as an objective scientific truth. If the app says turn left, we turn left. If the
Yeah.
wall map shows a line between two countries, we just accept that reality.
Right.
But we rarely stop to think that a human being, or, an algorithm written by a human,
Yeah.
had to decide what to show us and, more importantly, what to hide.
It's true. We tend to view maps as a mirror of reality, but they're really more like a painting. Or, honestly, better yet, an argument.
An argument. I like that.
Because you can't represent a complex, three-dimensional, ever-changing world on a completely flat surface
What?
without making massive compromises.
Yeah.
And that's really what we're digging into today. We're doing a deep dive into the cartographer's craft, fundamentals of spatial analysis.
The AP Human Geography holy text, basically.
Exactly. We're going to strip away that objective veneer of geography and look at the actual choices being made underneath.
We're basically giving you, the listener, a decoder ring for the world. We want to move beyond just reading a map to actually analyzing the intent behind it.
And to do that, we have to start with the basics of the toolkit. The source material divides the entire universe of maps into two main buckets.
Two very different buckets with very different goals, right?
Right. The first is what we call reference maps,
These are sort of the utility players.
pure utility. Their only job is to tell you where something is.
Okay.
So if you're looking at a political map to see where the border of France is, or a physical map to see where the Himalayas start and end,
Or a roadmap to navigate traffic.
yes, most commonly.
Mm.
If you're doing any of those things, you are using a reference map.
The goal there is just accuracy. Get me from point A to point B without driving into a lake.
Precisely. It's about location and navigation.
Mm.
But the second bucket is where the real intrigue happens. These are the thematic maps.
The text actually calls these the storytellers.
They are. A thematic map doesn't care about showing you every street corner. It cares about showing you a pattern.
Okay, so how does it do that?
It focuses on the spatial distribution of a specific type of data. So that could be average income, temperature, voting habits, whatever. It's asking how and why, not just where.
And this is where things get tricky because there are so many ways to visualize that data.
Oh, absolutely.
And each way tells a slightly different version of the story. Like the first one the text highlights is the choropleth map.
Choropleth. I know it sounds like a weird disease, but it's actually the most common data map you see.
It's the one with the colors, right?
Yeah, it uses shading or colors to represent values in specific regions.
We see this every 4 years in the U.S. The election maps, red states, blue states.
That is the classic example. You color code a geographic area based on a data value.
Right.
The source uses the example of Anglican population density in Australia.
Right.
Darker shades for higher density, lighter for lower. It's very intuitive.
But isn't there a massive trap with choropleth maps? I mean, going back to the election example, you look at one of those maps and it looks like the entire country is painted red,
Yes.
but the actual vote count must be nearly tied.
You've hit on the fundamental flaw of the choropleth.
Yeah.
It values land over people.
Ah, okay.
Think about it. If you have a massive, empty rural county with 5 people in it, and they all vote for Party A, that huge chunk of the map gets colored in completely.
Right.
Meanwhile, a city with 5 million people might just be a tiny dot of a different color. Your eye is drawn to the large area, not the dense population.
So the map is technically accurate, but visually it's completely misleading.
Which brings us to the cartographer's counter-response, the cartogram.
Oh man, these things look absolutely insane. It's like looking at the world through a funhouse mirror.
They are jarring, I'll give you that. But they are honest in a way. Choropleths aren't. A cartogram intentionally distorts the physical size of a region based on the data.
Okay, so if we stick with that election example.
A cartogram would shrink those giant, empty rural counties down to almost nothing and blow up the cities until they look like giant balloons.
So you're sacrificing the geographic shape entirely to show the weight of the data.
Exactly. The source mentions this map of global organic farming output.
Oh, right, where Australia looks like a massive swollen continent.
Yeah, because they have so much of it. And that visual shock is entirely the point. It forces you to confront the data, even if it breaks your mental image of what the world should look like.
Let's look at another tool in the bag, the graduated symbol.
This one is a bit of a middle ground. You keep the map looking normal, but you place a symbol usually a circle on top of each area. And the size of that circle corresponds to the value.
So if we're mapping wealth in Europe, a rich nation gets a big circle, a poorer nation gets a small dot.
Spot on. It's a lot cleaner than a cartogram because you can still recognize the countries underneath.
Unless the circles start overlapping.
Right. It can get very messy if you have too much data packed together.
Now, I really want to spend a minute on this next one because it connects to one of the most famous detective stories in all of science, the dot distribution map.
The John Snow map. This is basically the genesis moment for modern spatial analysis.
So for those who don't know, we're back in 1850s London. People are dying of cholera left and right.
A terrifying time.
And the leading scientific theory at the time wasn't germs, it was miasma. Bad air.
They literally thought the fog itself was killing people, so everyone is looking up at the sky. But John Snow, a physician, suspects it's something else.
He suspects the water.
He suspects the water, but he needs proof.
So he essentially conducts a census of the dead.
He takes a map of the Soho district and places a small black dot at the exact address of every single cholera death. 1 dot, 1 death.
And when he just looked at the list of addresses on paper, it didn't mean much, right?
No, it's just a tragic list. But when he visualized it spatially,
He saw the cluster.
a massive, undeniable cluster of dots right around the Broad Street water pump. And crucially, he also saw where there weren't dots.
Like the local brewery where workers drank beer instead of water.
Exactly. That pattern, that clustering, was the smoking gun. He got the handle removed from the pump, and the outbreak stopped.
It's just a perfect example of why this matters. A list of addresses is just data, but a map showing a cluster is information. It turned a statistic into an actual solution.
Beautifully said. Oh, and we shouldn't skip the last thematic type the text mentions, isolines.
Oh, right, isolines. That's the continuous lines connecting equal values, like weather maps showing temperature zones or elevation maps.
Right, you see those topographic maps with the swirly lines? Those are isolines.
Good catch. But going back to John Snow, that leads perfectly into the next big concept, spatial analysis. Because he wasn't just drawing dots, he was analyzing the why behind the where.
Right.
And the source mentions two key patterns geographers look for, clustering and dispersal.
Clustering is what Snow saw. It's agglomeration. Things packed tightly together.
You see this with high-rise apartments in Manhattan or tech startups in Silicon Valley.
Exactly. Humans and resources tend to clump together for efficiency or just for social reasons.
And dispersal is just the opposite?
Dispersal is when things are scattered, and usually it's intentional. Think of large-scale industrial farms out in the American Midwest.
You can't cluster those.
No, they need space. Or think of public schools. You don't want 10 elementary schools on one single block. You want them dispersed evenly so every neighborhood has access.
So when you look at a map, you should immediately be asking, are these things clumped together or are they spread out? And why?
Exactly. But there's another layer to this analysis that I think trips people up, and that's the concept of distance.
It seems so simple, though. Distance is just math. It's 5 miles to the store. It's 3,000 miles to London.
See, that is absolute distance. It's measurable. It's a standard. It never changes. But humans don't actually live in absolute terms. We live in relative distance.
I love this concept. This is the is it worth the drive metric.
Think about it. If I tell you a restaurant is 5 miles away, that means absolutely nothing until you know the context.
Right.
At 2 a.m. on an empty highway, that's 5 minutes. During rush hour in Los Angeles, that could be an hour.
Yeah, the absolute distance hasn't changed at all, but the relative distance measured in time and frustration has completely skyrocketed.
The source actually brings up a really powerful example of this regarding social barriers.
Yes, the gap between a wealthy neighborhood and a distressed neighborhood.
They might be physically separated by a single street,
Mm-hmm.
maybe 50 feet of absolute distance.
Right?
But in terms of economic opportunity, social networks, and lifestyle, the relative distance is an absolute chasm. They are worlds apart.
That's a really sobering way to look at a city map. You see these lines that look perfectly permeable, but socially they're basically concrete walls.
And we do the exact same thing with direction. Well, we technically know what north, south, east, and west are. Those are absolute. But if you ask someone for directions, they don't say, head northwest for 400 yards.
No, they say turn left at the Starbucks, and if you hit the gas station, you've gone too far.
That's relative direction.
Yeah.
We navigate our world by landmarks and cultural nodes, not by compass headings.
Okay, I want to shift gears to the topic that I think is the most counterintuitive part of this whole cartographer's craft.
Let me guess. Scale.
Yes,
Huh.
the terminology of scale. It is a trap.
Ah, the trap. It really is.
Every single time I read large-scale map, my brain immediately imagines a map of the whole world. Because the world is large, but that is 100% wrong.
It is the exact opposite. And it's because scale refers to the mathematical ratio, not the physical subjects.
Right.
But let's simplify it. Forget the math for a second and just think about a camera lens.
Okay, I'm picturing a zoom lens.
If you zoom all the way in to take a picture of a bug on a leaf, you are seeing a tiny area, but with massive detail. You can literally see the veins on the wings. That is a large-scale map. Large detail zoomed in.
So a map of my specific neighborhood or like a blueprint of a house, that's large scale.
Correct. Now, zoom the camera all the way out to take a picture of an entire mountain range. You are seeing a huge area, but the individual trees and bugs are completely invisible. The detail is tiny.
Okay.
That is a small-scale map. Small detail, zoomed out.
Okay, so large scale equals zoomed in, small scale equals zoomed out. But why does this matter so much? Why do we need to distinguish this?
Because scale determines the story. If you look at a disease outbreak on a small-scale map, say a zoomed-out map of the entire U.S., and you see a giant red dot on a state, you might think the whole state is infected.
It creates instant panic.
Exactly. But if you switch to a large-scale map zoomed in, you might realize the outbreak is actually totally contained to a single hospital ward.
So you can manipulate public perception just by changing the zoom level.
You can hide huge problems by zooming out, or you can exaggerate tiny ones by zooming in too far without giving context. Scale is a narrative choice.
Which brings us to the ultimate narrative choice. The lie we started the deep dive with. The projection.
The projection. This is the mathematical tragedy of mapmaking.
Tragedy. That's a little dramatic.
It is a tragedy because you have this beautiful, perfect, three-dimensional sphere, the Earth, and you are trying to force it onto a flat, two-dimensional piece of paper or a flat screen.
Right.
It is physically impossible to do that without breaking something.
The source uses the orange peel analogy, which I think is absolutely perfect. If you peel an orange in one single piece and try to smash the skin flat on the table, what happens?
It tears, it stretches, it ripples. You can't flatten it perfectly. And that is exactly what happens to our continents. So cartographers have to choose what to distort and what to preserve.
And the text uses the acronym SADD for this.
Right. SADD, shape, area, distance, and direction.
Every map you see distorts at least one of those four things.
It has to. And the entire history of cartography is basically a series of arguments about which distortion is acceptable.
And the reigning champion of this argument for centuries has been the Mercator projection.
The Mercator, created way back in 1569. If you close your eyes right now and picture a world map, you are almost certainly picturing a Mercator.
It's the one where Greenland is the size of Africa.
Which is wildly inaccurate. Africa is actually 14 times larger than Greenland. 14 times. But on the Mercator, they look completely equal.
So why on earth did we settle on a map that is so fundamentally wrong?
Because it wasn't made for you to learn geography in a classroom. It was made for sailors to not die at sea. Gerardus Mercator designed it so that if you drew a straight line on the map, it represented a constant compass bearing. It preserved direction perfectly.
So if you were navigating across the Atlantic in the 16th century, the Mercator was the greatest invention of the age.
Precisely. But the massive trade-off was area.
To keep those compass lines straight, he had to stretch the map as you move away from the equator.
So the poles get stretched to infinity. That's why Greenland and Antarctica look colossal, and the equatorial regions look shrunken and insignificant.
And the source points out that this isn't just a quirky math lesson. It affects how we see the world today. It mentions that this projection has been heavily criticized because of the social implications.
Right. It's an impartial fact that the Mercator shrinks the equatorial regions, where historically many colonized nations are located, while blowing up the size of North America and Europe.
So the critique is that if you grow up seeing the global north as massive and dominant and the global south as tiny, that naturally shapes a subconscious bias about importance and power.
Absolutely. The text frames it as a colonial worldview baked into the walls of every elementary school classroom. And that exact critique is what led to the huge backlash in the 1970s, the Peters projection.
The Peters projection. Boy, is that an ugly map.
It is aesthetically challenging, let's say that. But Arno Peters argued that the Mercator was inherently Eurocentric because it diminished the developing world. So he created a projection that preserved area perfectly.
This source calls it a social justice map. On a Peters map, Africa is huge, South America is huge, Europe is tiny.
But to get the size right, he had to completely sacrifice shape.
Right. He essentially put the continents through a laundry wringer.
They look stretched, long, and droopy. It looks wrong to our eyes because we're so used to the Mercator, but mathematically speaking, the physical sizes are correct.
It really feels like we're stuck between a lie that looks good, the Mercator, and a truth that looks terrible, the Peters. Is there a middle ground?
There is. It's called the Robinson projection. You'll see this one a lot in National Geographic. It's the ultimate compromise.
The politician of maps.
Exactly. It doesn't try to be perfect at anything. It distorts the shape a little bit. It distorts the size a little bit. The direction's a little off. But nothing is terribly wrong. It creates a visually pleasing balance. It's the good enough map.
And then for the purists out there, there's the orange peel map, the good Homolecene.
Oh, I have a soft spot for this one.
It looks crazy.
It looks like the skin of the Earth has literally been peeled off and flattened. It has giant gaps, interruptions in the oceans. But by cutting the oceans, it allows the continents to maintain their true size and their true shape.
But you can't use it for navigation at all because you just fall off the edge of the paper in the middle of the Pacific.
Right. Completely useless for sailing, but absolutely brilliant for showing human data on land masses.
It really highlights that every map has a highly specific job. Like if you're flying a plane over the Arctic, literally none of these work. You need a polar projection.
Which looks down from the top of the world. On a normal map, a flight from New York to Dubai looks like a giant curved arch. On a polar map, it's just a straight line. It changes your entire understanding of proximity.
So we've covered a lot of ground here. We've gone from reference and thematic maps to clustering to the inevitable distortion of the sphere.
We have.
But I want to circle back to you, the listener. The next time you see a map, whether it's on the news talking about an election or in an article about climate change, what is the mental checklist you need to run through?
I think it comes down to 3 basic questions based on this framework. First, what is the scale? Is the author zooming in or out to hide something?
Check the zoom. Got it.
Second, how is the data visualized? Is it a choropleth that's letting empty land completely dominate the narrative? Or is it a cartogram that's distorting shapes just to make a point?
And third,
What is the projection? Is this map preserving size or is it preserving shape? Because once you know what the mapmaker sacrificed, you know what they prioritized.
it's really about recognizing that a map isn't a fact. It's a product.
It is. A map is a human creation filled with human biases, human goals, and human limitations.
So I'll leave you with this final thought. If every single map requires a cartographer to choose what to include, what to exclude, and how to mathematically distort reality just to make it fit on the page, is it even possible to have a truly neutral map? Or is every single map, by definition, an argument for a very specific way of seeing the world?
That is the ultimate question. The map is not the territory.
Something to mull over the next time you blindly follow that blue line on your phone. Thanks for taking this deep dive with us.
Keep looking closer.